Session 1, OpenStack Wallaby, Getting to Know OpenStack. My name is Ram. So, what is this session? What we will learn in this session is getting to know OpenStack, understanding the cloud components, history of OpenStack project from Austin to Wallaby, and OpenStack distribution and vendors. So by the end of the session, what will be the change in the profile? You'll be able to define what is cloud, what are the service models of the cloud, what is the offerings in the cloud, who all are vendors of OpenStack, who all supports OpenStack, what is the OpenStack architecture. So by the end of this lecture, you will have a great understanding of OpenStack as a cloud and cloud in general. If somebody asks you what is cloud computing, how do you define it? We have a fixed definition. The National Institute of Standards and Technologies, that is NIST, definition is considered the established definition for cloud computing. And this NIST definition is cloud computing is a model of providing widely accessible and convenient access via network to a common set of adjustable computational resources on demand. For example, networks, servers, data, storage, etc. These resources can be promptly allocated and released with minimum customer efforts spent for management and interactions with service provider. This is the definition of cloud computing. If you want to understand further, we can say that cloud computing is multi-tenant solution provided by vendor. Tenant refer to customer. If Oracle is cloud service provider, if Amazon is cloud service provider, then IBM, or as an example, HDFC Bank or any other bank or any other company who are customer to Oracle Cloud Computing will be tenant. So tenant is a customer or client for that cloud. So multi-tenant refer to multiple customers access the cloud computing resources. So cloud computing is multi-tenant solution provided by a vendor. Automated backup, pipeline, service level agreements, and maintenance. All these are part of cloud computing, mandatory component of cloud computing. Elastic means scalable, pay as you go. You don't have to spend anything upfront. Scale up or scale down. Scale up or down means we call it as vertical scalability. There are two types of scalability: horizontal scalability and vertical scalability. Horizontal scalability is where we are adding more resources. For example, converting one cat into 100 cats. Vertical scalability means adding more power. For example, converting a cat into a tiger. Think of that visual picture and you will understand scale up or scale down, meaning adding power or reducing power. There are two types of scalability, as I said. Web and mobile access from anywhere. So means accessibility. Access from air, from command line, from web, from mobile, from anywhere. Automated upgrades to the resources, to the services. All this is cloud computing. And modern web-based integration. These are features of cloud computing. These are properties of cloud computing. These are USPs of cloud computing. This is what makes the cloud computing. Service models. Cloud service models are differ by the level of customer control. As a customer, as a tenant, what is your control? What level of access you are getting? That defines, that differentiate the service model. For example, infrastructure as service, IaaS, platform as a service, PaaS, software as a service, SaaS, or software as a service, SaaS. All these actually decide the boundary where you enter as a customer and where you stop. That okay, this is my borderline, this is my boundary, now I can't go beyond this. The service model decide this boundary. Let's understand infrastructure as service. The user gets control over all levels of software stack above the cloud platform, which means the virtual machines, network, space volumes at data storage system. The user is an administrator of the operation system and all the work above it to the applications. OpenStack is an example of infrastructure as a service. Then platform as a service. Platform, meaning platform is given to you. So you don't have control to the infrastructure. You get the platform. So cloud of this model can exist inside the cloud of infrastructure as service because we are offering platform as a service. So platform as a service refer to installation or installed software on the top of the infrastructure as code or infrastructure as service. So cloud of this model can exist inside the cloud of IaaS model. User get control on the level of platform applications built. For example, application server, libraries, programming environments, and databases. So when you get a ready platform, I have very good example of platform as a service for Oracle supported services I'd been delivering for Oracle. And a very good example here is when I demonstrate and I delivered the training on Oracle Developer Cloud, that is Oracle Dev CS, which is nothing but Visual Builder Studio instance where you can create a CI/CD pipeline, continuous integration, continuous build process for DevOps. That is platform as a service. Similarly, Terraform installed on the Oracle Developer Oracle Cloud, which is offered as a service. A registry for images, Docker containers and images is a solution, is a platform as a service. So when platform is offered to you, fully managed platform offered to you as a service, that is platform as a service or PaaS. The user does not control and does not administer the virtual machines where these platforms are installed, where this Visual Builder Studio is installed, where this integration that OCIR Oracle Cloud Infrastructure Registry is installed. User does not control that. User does not administer that. And operational systems deployed on them, you don't have any control on them. Data storage, you don't have any control. So you don't have any control on the infrastructure, but you have access to the platform. Red Hat OpenShift is an example of platform as a service because OpenShift deployed on Red Hat Cloud offered to the end customer is an example of platform as a service. Similar to this, OpenShift is nothing but Kubernetes. Similar to this, Oracle Cloud Infrastructure has OKE, that is Container Engine for Kubernetes, which is codenamed as OKE in Oracle Cloud. So OKE in OCI, OpenShift in Red Hat, all these are examples of platform as a service. Software as a service, very quite simple. Like if you are using Google Doc, Excel sheets, or you are using any other similar service, that is software as a service is offered. So software as a service, in this case, the user level of control is for only the application itself. The user would be unaware of what the virtual machine or the operational system is and would only work with the application. So not access to platform, no access to infrastructure, only the application. So user will get user ID and password, and user will be able to access the application only, not even the platform. Examples of such products are Google Docs or Microsoft Office 365, where you can access the document on Google Docs from anywhere. Microsoft Office 365. So they are live solutions offered as software as a service for you. Cloud service management responsibilities. Let's understand from with animation, with a figure to divide the boundary line which I theoretically explained in previous few slides. But let's understand from this figure that will make it more clear. Infrastructure as service, platform as a service, and software as a service. From these perspective, customization, application, and platform, and the infrastructure. So infrastructure is the lowest level. So if we try to understand these service model from perspective of control of the tenant or control of the customer, control of the client on infrastructure, platform, or application, what is your boundary, what you can do? In infrastructure as code, you can customization, applications, and platform. You are responsible as a customer, as a tenant. So cloud consumer or tenant manages customization, applications, and platform. So as a customer, you are responsible for this customization or application deployment or platform configuration. You manage everything. So what you get is infrastructure as a service. So the cloud provider manages the infrastructure, provide to you, and you use that to provision your platform, to configure platform, manage your applications and customizations. Similarly, if we say platform as a service, then you can have control on application and customizations. So cloud consumer or tenant manages customization and applications, and platform and infrastructure is managed by service provider. So cloud provider manage platform and infrastructure. Similarly, if you're talking about software as a service, the customization will be taken care by the cloud consumer or tenant. So cloud consumer or tenant manages the customization, application, platform, and infrastructure. All these are managed by cloud provider. So cloud provider manages the application, manages the platform, manages the infrastructure. So this is the boundary line. If you look at here, the line goes like this. So responsibility of the cloud service provider goes on increasing as we move from infrastructure as code to software as a service. Infrastructure as a service to software as a service. Deployment. How do we deploy cloud? There are different types of deployments, different type of models. 4 deployment models of the cloud platform implementations are popular. One is private cloud. Second is public cloud. Third is community cloud. And fourth is hybrid cloud. Let's get into the details of each one of them one by one. Public cloud, share resources, pay as you go. Models are common. In public cloud, share resources, that is pay as you go models are common. OpenStack public cloud is available in 60 plus data centers globally. AWS is public cloud. Oracle Cloud Infrastructure OCI is public cloud. DigitalOcean is public cloud. There are public cloud because anybody can subscribe and select the payment model and use the resources on pay as you go. Then private cloud, not the entire public, they are not accessible to the public. They are dedicated and are specific to a company. For example, HP has its own data centers. HP has its own cloud. So it is dedicated to a single user, can be hosted private cloud or in a vendor's data center of yours, or a remotely managed private cloud. Private means, as the name suggests, private, it is yours. Then we have hybrid. So hybrid cloud is a mix of private cloud and public cloud, orchestrated together to meet the company needs. For example, a company says, no, I want the data center in my place, but take services from the public cloud as well. I have a very good example here. Oracle has some offering called Cloud at Customer. What they do is they set up the data center at customer premises, but they offer all the features, all the services of the cloud themselves. So it is fully managed cloud at customer data center. So infrastructure, data center, all these costs are managed by the customer, and Oracle offers the management responsibility of the cloud. So this is a model which is hybrid, which is private also, but using public cloud features also. That is hybrid cloud. Then we have community cloud, which is actually a very good example. Is any specific government may have their own cloud or a specific type of community. Here community does not mean the public at large. No, it is not that. What you hear from source code or the software, it is not that. Community here refer to a specific target audience. One example is a bank. Banking system, if they have their own cloud for their own community, that is community cloud. In India, I can say that, okay, we have a cloud called NIC Cloud, National Informatics Center. This cloud, NIC Cloud, is community cloud because it is only available for government offices. It's not for private or not for public. It's not for anybody else apart from government offices. So that is community, targeted audience. Let's understand the components that make up the OpenStack. OpenStack project, also called as Cloud Operational System, consists of a number of different projects developing separate subsystems. Any OpenStack installation can include only a part of them. Some subsystems can even be used separately or as a part of any other open source project. In fact, I have a very good example here, Swift Object Storage, which is a part of OpenStack project, is used in Oracle Cloud Infrastructure, OCI also, with the name object storage. They don't use the Swift as a word there, code name there. They simply call it as object storage. But behind the screen, I know it very well, they are using Swift. Their number is increasing from version to version of OpenStack project, both through the appearance of new ones and functionality split of existing one. As an example, Nova Volume service was extracted as a separate Cinder project. Earlier it was Nova service, but now it is split and get at a, it's available as a independent project with the name Cinder. Each project has its own documented set of representational state transfer, that is REST, representational state transfer, application programming interface, that is API. So every project, each project has its own REST API, its own command line utilities and native Python interfaces which you use to communicate with the service. Each service, we are going to understand with examples. It is the theoretical explanation very much important, very definitely it is needed for understanding the overall cloud operations. So what is OpenStack? OpenStack, developers and admins works in OpenStack through application programming interface, through APIs. They make REST API calls. Programmable network, which has computer resources and storage resources. It's a programmable infrastructure that lays a common set of APIs on the top of compute, networking, and storage. And then what we do is we create virtual machines, containers, and bare metal machines These are additional extensions to OpenStack. So it's one platform for virtual machines, containers, and bare metal machines. So this is what OpenStack is. What is the architecture of OpenStack? This is just a bare minimum architecture we are trying to understand here. We have different services like Nova Compute, Cinder block storage, Swift object storage, Nova scheduler, Nova network or Neutron. It is now the code name is Neutron. Then we have Nova API. Then we have Glance API. So starting with this queue server, this communicate with other Nova components. Asynchronous communication is happening. So this is queue server, message queue. And this RabbitMQ is used here for messaging, for communication or coordination. If you see, these are all double-headed arrows. So queue server allow the communication between other members, other services. This Glance API lookup and retrieval system for virtual machine images when you launch an instance in the cloud. This is a Glance API service. Nova API is interface to the outside world to interact with the cloud infrastructure, that is OpenStack API, EC2 API. This is the interface, Nova API. Then we have Nova Compute. Its compute worker deals with instance management lifecycle to launch your virtual machines, virtual instances. Then Cinder block volume or block storage. It is persistent storage management of LVM-based instance volumes. Cinder provides persistent block storage compatible with Amazon Elastic Block Store, EBS. Then we have Swift. It is distributed, eventually consistent virtual object store for OpenStack. It is analogous to Amazon Web Server S3 bucket or store, object store. Then we have Nova Scheduler. Nova Scheduler maps the Nova API calls to appropriate OpenStack component where OpenStack instance will be launched. It will take the calls and it will map that with the appropriate component, because event ultimately any instance would need block storage, would need Neutron network infrastructure, would need a block storage image to launch the operating system. It will need multiple resources. So scheduler will coordinate and will map those calls to the appropriate OpenStack component as we need while launching the instance. Then Neutron, Nova network or Neutron, it deals with network configuration of host machines. So this is the architecture. This is not the complete architecture, but yes, it gives a direction that okay, we have independent services which communicate with each other, and message queue is a message queue service, RabbitMQ, which pass the communication messages from one service to another and do the coordination part or message transfer part. So this is the architecture of OpenStack. OpenStack is open source. Does that really matters? Of course that matters. Choices and control. Because it is open source, so it gives you ability to choose between and switch between vendors. There are different vendors, so many vendors available who are offering OpenStack. So you can switch between the vendors. If you are not satisfied the services with the services of one, you can switch to another. Widely adopted open source APIs are new standards. Ability to control or directly influence the roadmap. Because you are open source, you can become the contributor and you can start writing and developing OpenStack services or contributing to them. It's a part of a vibrant community to share knowledge and help each other. So these are good reasons that open source matters. What are OpenStack principles? Principle number one, open source. Source code is available. Principle two, open design. Design is open. Principle three, open development. Principle number four, open community. So open source, open design, open development, open community. These are all principles of OpenStack. Let's understand the core services of OpenStack. For example, Nova Compute. This is one of the basic services in OpenStack Compute. This service is installed on all nodes. Uh, well, not precisely. I will say that where instances are to be launched, because I am referring to the compute instances. So wherever you have to launch instances, you need to install Nova. In technically, if I say that Nova compute is hypervisor, and we need to install the hypervisor on the hardware where you are planning to launch the instances. So this service is installed on all the nodes, which will act as hypervisor. It manages the level of abstraction of virtual equipment, that is processors, memory, device, block devices, and network adapters. Nova provides the management of instances of virtual machines, addressing the hypervisor. As I said, it is hypervisor or virtual machine monitor, because this is where virtual machine will be launched. So it provides the management of instances of virtual machine, addressing the hypervisor and giving command as it is launching and stopping the instances. OpenStack technologies are independent of the hypervisor being used, because this is one level above the hypervisor. Point to be noted. Principally or primarily, OpenStack development and testing are being made for kernel-based virtual machines, that is KVMs, kernel virtualization modules. What is KVM? KVM has been a part of Linux kernel since 2007, and it requires virtualization hardware support on servers with standards architecture AMD 5 and Intel VT-X. This Intel VT-X is available in your Intel-based desktop or laptops, and by default it is disabled. So when you purchase a laptop, this setting is disabled. That is called Intel VT or Intel virtualization. So you need to start your system, get into the BIOS setup. You need to figure out where this location is, where this setting is, and you need to enable that in order to create virtual machines on the top of that hardware. So it is required. QEMU, which is short for quick emulator. It is used for input-output devices for emulation in GNU Linux. You can check whether the support is turned on and the processor supports one of the technologies by executing this simple command. The command is grep-e svm or vmx from /proc/cpu info in your Linux machine. You should see svm or vmx among the flags supported by the processor. OpenStack Networking, Neutron. OpenStack Networking or Neutron is responsible for network connectivity. Users themselves can create virtual networks and routers, as well as set up internet provider, that is IP addresses. One of the mechanisms provided by Neutron is called floating IP. Very interesting concept. Imagine your virtual machine is available on this node, physical host, and this machine is transferred to another host. So the floating IP refer to this IP which was pointing to this machine on this physical host will be floating and will point to the machine. So in other words, you can see that it will move along with the machine. That's called floating IP. Using this mechanism, virtual machines can get externally fixed IP address even though they are moved from one host to another. Then we have Keystone Identification Service. OpenStack Keystone Service is centralized catalog for users and services that they have access to. In other words, it is identity provider, authentication, token generation, authentication of the request, whether the request is valid or not, whether it should be allowed or not, is decided by Keystone. You log into the system, you will be authenticated and you will be given a token. So whenever you make any request, that token will be your identity, and this token will be passed. Any service which you are sending request will confirm from Keystone that I have this token, I got this request with this token. Do you approve this token? Is it valid token? Do you approve the service? Then Keystone will respond to that. So because you know what, as we said, discussed in the architecture, there are so many components. So we communicate by means of the token which is provided by Keystone, and so identity service. So you go to Keystone, you grab a token, you launch a service. This request is launching, probably taking control of another service or needing access to another service. So how do this service would know, how this service would know whether this request which I received from this client is valid or not? So again, this service will coordinate with Keystone to check the validity of the request by means of the token. So Keystone provide identification service to you and your request which travel from one service to another in OpenStack Cloud. It performs as a united authentication system of the cloud operating system. It checks the validity of users' accounts and the accordance of users to the OpenStack project and roles. And if it is compliant, it gives the token for access to other services. Then image service. OpenStack image service with the name Glance, it runs a catalog of virtual machine images which users can use as templates to run instances of virtual machines in the cloud. This service also delivers the backup functionality and snapshot creation. Glance supports many different formats including VHD, VMDK, VDI, ISO, QCOW2 and AMI. All these formats of images are supported by image Glance service. Then Cinder block storage, that is OpenStack block storage, which is code named as Cinder. OpenStack block storage or Cinder, this service manages block storage which can be used by running instances of virtual machines. This is permanent data storage for virtual machines. Snapshot can be used for data saving and restoring or cloning. So this is exactly how it is implemented. It is created on the top of LVM, logical volume. So it is nothing but you can think of that it is the LVM in the cloud, logical volume in the cloud, and at the back end it actually use LVM. And then Swift is object storage. OpenStack object storage is Swift. This service is one of the two original projects that appeared in OpenStack besides Nova. Originally, it was called a Rackspace Cloud Files. This service is an object storage which allows users to store files, which may be machine files, maybe PDF, directories, images, videos, any kind of file can be stored into the object storage. The Swift object storage has distributed architecture allowing horizontal scaling. Horizontal scaling, as I said, adding more cats. One cat converted to 100 cats. So one virtual machine, one physical machine, one data store, adding more data store, more physical machine. So you get the scalability. You get more number of instances. So it allows that scalability, redundancy, that is the duplicacy of the data, so that if one goes down, your data is still available intact, and replication for failover purpose. These are all built-in support. You don't have to do anything manually. I'm talking about redundancy and failover. Swift is oriented mostly to static data such as virtual machines copies, backup copies, and archives. As I said, images. I give the example of images, videos, machines, PDFs. They are not the kind of data which you manage or you change. They are not the document which you change. So they are not software. So basically, as I said, this is object store. Then we have orchestration service, heat. Orchestration service has a main task of application lifecycle provision in cloud infrastructure. Using the template in AWS Cloud Formation format, this service manages all other OpenStack services, allowing the creation of virtual machines, volumes, floating IPs, users, security groups, etc. Heat can also make applications scaling automatic by using data from Silometer service, which is metering service. Templates describe relation between the resources which allow heat service to make API OpenStack calls in the right order. For example, first to create the server and then to connect volume to it. Then we have the dashboard, OpenStack dashboard, which is Horizon. OpenStack dashboard or Horizon provides administrators and users with a graphical interface to access, provision, and automate deployment of cloud-based resources. The design accommodates third-party products and services such as billing, monitoring, and additional management tools. So it is an excellent tool, graphical interface tool to manage all your cloud resources. The dashboard is also brandable. I have seen that because I've been deploying OpenStack in Red Hat and Ubuntu. So it is brandable. You can change the brand for service providers and other commercial vendors who want to make use of it. History of an OpenStack project. How it all started. That's an interesting story. Take it as a story, not beyond that. The cloud operational system, OpenStack, was established in June 2010 as a project that connected NASA's NOAA virtual servers development system and its US hosting provider Rackspace Swift data storage system. So the credit goes to NASA's virtual servers and Rackspace Swift data storage systems. The first version under the code name Austin was released in October 2010. In SX version, the second version, Horizon Management Web Console and Keystone Identification Services were added. The heat, orchestration, and Silometer services were added in Havana version. So every version, every release, if you go by history, has something new, some extra features, some enhancements, some breaking, so reorganizing. This release is so fast, every 3 months, 3, 4 months, 5 months, you see a new release. Application credentials, system scope, and system role assignment, unified limits, and flat enforcement and project tags were added in Queen's version. They were not there before that. Refinement of ironic, that is bare metal provisioning, improvements to upgrade process, default roles, strict hierarchical enforcement model, application credentials capability lists, and improved multi-factor authentication are some of the highlights of Rocky, the 18th release of OpenStack. Wallaby, the 23rd release of OpenStack, makes improvement to the role-based access control and integration with other open source projects including Ceph, which was not there, Kubernetes, which was not there, and Prometheus for monitoring to strengthen open infrastructure for cloud native applications. More than 17,000 code changes authored by over 800 contributors from 140 different organizations and 45 countries were merged into the release I'm talking about 23rd release of OpenStack. The source of this information is this URL openstack.org/software/wallaby. Cola is production ready containers and deployment tools. Added support for Prometheus version 2, which is nothing but a data store for time series, database for time series data. Magnum API service updated version for Kubernetes and container D, and Cinder, that is block storage service, added support for Ceph backend driver Ceph iSCSI. The Ceph extension or Ceph enhancement is available in version 23 edition, which is Wallaby. OpenStack development. At present, OpenStack is being developed under the control of OpenStack Foundation with about 25,000 individual members and more than 800 corporate members. Almost all IT market leaders support OpenStack. The main programming language of OpenStack is Python. The code itself is distributed under the Apache 2 license. Check for OpenStack contributor at this URL, that is stackanalytics.com. OpenStack distribution and vendors. OpenStack is a cloud infrastructure development project, but not a product. It's not a product. Many companies take part in OpenStack development, create their products and distributions on the basis of its code, often using their proprietary components. This situation is similar to GNU distribution creation. You can find full list of major distributed at this distributions at this URL openstack.org/marketplace/distros. Some of the distros are SUSE, which is SUSE OpenStack Cloud. There are more. SUSE OpenStack Cloud is the enterprise private cloud solution of choice. Designed for high availability, rapid deployment, and ease of use, along with a widest hypervisor support and interoperability, it delivers the agility and control to drive innovation. And we have Ubuntu. The canonical OpenStack is fully integrated, optimized combination of Ubuntu and OpenStack. Rocky, Queens, and Pike, and Mitaka, and other, even the Wallaby and Zena, the latest release. With powerful tools to operate your cloud, Canonical OpenStack is available with enterprise support as a fully managed service. Then we have Mirantis Cloud. Mirantis Cloud Platform (MCP) is unified open cloud software stack for managing bare metal, virtual machines, containers. MCP include OpenStack for bare metal and virtual machines, Kubernetes for containers, Ceph for storage, and Drivetrain for LCM, and Stacklight for open source systems. So these are some of the distributions and vendors. Also, we have one distribution from IBM, that's IBM Spectrum Scale for object storage. IBM Spectrum Scale and OpenStack Swift provides an enterprise class object storage solution that efficiently stores, distributes, and retain critical data. You can access your data from file or object interface seamlessly and manage data uniformly. Then we have Thick Cloud OpenStack from Lenovo. Lenovo Think Cloud OpenStack is cloud operating system used to manage various computing, storage, and network resources of data center. Think Cloud OpenStack can provide large-scale, stable, reliable cloud computing environment. Then Red Hat its own flavor, Red Hat OpenStack platform, uniquely co-engineered together with Red Hat Enterprise Linux to ensure stable and production-ready cloud. Red Hat OpenStack platform provides an open, scalable, and secure foundation for building a private or public cloud. Then we have Fusion Sphere from Huawei. Fusion Sphere OpenStack combines open source stack and Huawei deep understanding of telecom industry, created an open, agile, reliable cloud operating system for enterprise and carrier customers to deploy private cloud, public cloud, and hybrid cloud. So these are some of the vendors offering their own packaged solution from OpenStack. And that's all for this session. Share your feedback at this email ID. For queries, you can call me on this number. Thank you so much for watching. Bye bye.